This is a demonstration video of the time travel debugging tool we've built for Node.js and the ChakraCore JavaScript engine. So to start off, we're going to do a quick review of existing Node.js programming practices and debugging tools by looking at a simple sort of coding sprint dashboard application using the popular Node.js HTTP server package. So we'll just launch Node in the usual way, giving it our top-level JavaScript file. It'll open up a server running on this local address. If we navigate to this page, it gives us some high-level information on the status of the coding tasks we have. And then if we click on a user, it'll show more information about tasks that are assigned to them, which file this task is in, comments associated with it, and it'll give a little breakdown on the average time they have per task in their to-do list. And we can click around and see other users have other tasks. But if we click on Aranesh, we see that he has the unfortunate value of infinity days per task, which doesn't quite make sense. And due to the really dynamic and sort of flexible nature of JavaScript, trying to print some of these unusual numeric values like infinity or nan or undefined is a problem. And so we've actually instrumented our HTML templating engine to check for these kinds of values and report these errors by both printing a message to the console and logging it for later debugging. Now, if we look at the source code here, we can search around, scroll around, and we'll find this error message is here under this if statement, which does indeed check for an infinity. And if we wanted, we could set a breakpoint at this line, reproduce the bug, look at the stack, make a guess about where it was coming from, maybe set another breakpoint and reproduce again to sort of narrow down the exact cause of the failure in the standard, sort of iterative debugging way. But with the time travel debugging and this time travel recording functionality we've added to Node, we can actually do something else. We can pass it a ttRecord flag, record, and we just give it a location that we want it to store all the time travel and program state information that it needs to record when it encounters an error. And if we fire this up, it'll start the server running again. We can refresh the page. We can click around as before, and when we click on Aranesh, we'll see that now it both prints the message, but our special logging information has also realized that this was an error message to print, and so it's written a time travel log to the location we specified. And this log is portable, it can be saved, it can be moved around, it can be replayed. It guarantees that we'll replay the execution exactly the same way every time. So what we can do now is, here's our version of Visual Studio Code that we've customized with time travel debugging features. And we've actually set the trace debug launch configuration to go and load that file, to look for the last occurrence of a telemetry error message in there, to set a breakpoint at that exact time in the execution, and then start the code running. So if we click the button, it'll start us up, it'll trigger this error message, and if you look, our timestamp here is 095388, which was computed from the date, current time. And if you look here, it is 095388, so exactly the same timestamp. So we're replaying dates and times, packet requests, asynchronous events, all exactly the same as during the original recording. Now we can also look at the call stack and we can see everything just as before, but now in addition to having the regular step, we can step back in time. So if we step back, you'll actually see message now becomes undefined. If we step forward again, even though we're calling date time now, the message gets generated exactly the same, 095388. So now what we can do is, rather than sort of guessing where we want to go back in the call stack or setting a new breakpoint, we can just simply step back one step at a time out of the anonymous function, out of our template function, back until we see where are we setting these values that we're actually templating, and we see days left in sprint, 10. The user task array.length is 0, so that's how we'll do our div by 0 and get our infinity, which if we want to check how that flows and track it carefully, we can actually follow these values back down into the function, getting exactly the same message, exactly the same behavior, again, stepping back and forth as much as we want. So this really shows the power of the time travel debugging functionality and the ability to record and replay these events exactly.